Good morning. Myself, Dr. A.M. Takle, working as Associate Professor in Mechanical Engineering Department, Sharad Institute of Technology, College of Engineering. Today's our lecture is on powder metallurgy, the advantages, limitations, and applications of powder metallurgy. Powder metallurgy actually it is a very vast subject and it having some wide range of applications, having some advantages and some limitations. The main application of powder metallurgy is a cutting tools. That carbide tools, it may be drill or any other tools, or indexable inserts normally manufactured from carbides, and the technique used to manufacture these carbides is powder metallurgy. Normally carbides, tungsten cobalt, tungsten carbide and cobalt is there, and through that using very fine powder these toolings are manufactured. Introduction Introduction of powder metallurgy. Powder metallurgy is a branch of metallurgy which deal with the production of metal and non-metal powders and subsequently manufacture of components by using these powders. Actually, powder metallurgy is a branch of metallurgy, that is material science, and it deals with the production of metal and non-metal by using powder metallurgy. The production of metals as well as non-metals are possible, and for this process required powder, and then squeezing is there for compactness of that powder. But initially that metal and non-metal powder is used to manufacture these components, that is powder metallurgy components like cutting tool or any other tools. Powder metallurgy components are manufactured of metal or metal and non-metal powders by through which powder metallurgy metal and metal manufacturing is possible, as well as metal and non-metal powder manufacturing is also possible. That is by compactness of metal and metal is possible, as well as the compactness of metal and non-metal is also possible. Compacting with simultaneous or subsequent heating at elevated temperature using a controlled atmosphere to develop metal or metal-like components with satisfactory strength and density. These two powders are mixed in a die, then compacting, that is pressing, will take place by subsequent operation like heating, that is powder is heated to elevated temperature in a controlled atmosphere. That temperature is maintained and is heated to a particular temperature, then compacting with simultaneous or compacting of that metal and non-metal takes place to develop metal or metal-like components, that is cutting tools like drills and inserts with satisfactory strength and density. We are getting very good strength and density of that powder metallurgy components. These components have unique and wide range of properties which satisfy the need of modern society in day-to-day life. The main advantage of powder metallurgy is it gives product with unique properties and also with wide range of properties, and which needs satisfy the need of modern society in day-to-day life. That is, it satisfied the need of society, just like I will give an example in cutting tools, that is in CNC turning or VMC machines. These cutting tools are manufactured by using the drills or cutting indexable inserts are manufacturing by using powder metallurgy technology, and we satisfied the cutting operation on a machine. It is possible to produce components with properties similar to the parent metal, whereas if the components are manufactured by melting, The alloy may have different properties from their parent material. Like in a casting, the final component may have different properties from that initial or parent material, but with the help of that powder metallurgy components, the property of final component remains same as that of properties of parent material. Production of refractory materials like tungsten, molybdenum, titanium, TH, etc. is possible without melting. Example, manufacture of ductile tungsten in wire form from lamp filaments. Such type of that tungsten, molybdenum, titanium, these metals can be manufactured. The composition of these products or alloys can be manufactured with the help of powder metallurgy technique, as well as in a lamp filament the tungsten wire is used and the tungsten wire is manufactured with the help of that powder metallurgy technique. Manufacture of cemented carbide cutting tools is only possible by powder metallurgy. I already told that cemented carbide cutting tools like drill or any other tools or indexable inserts are possible to manufacture with the help of only powder metallurgy technique. The melting point of the carbides which are used for the manufacture of these cutting tools are extremely high and hence melting is not possible. Hence such cutting tools and diamond tools for cutting glass and tungsten alloys are made by powder metallurgy. To cut the very hard material, it requires that carbide or diamond tools to cut the glass or tungsten alloys. So, to manufacture this cutting tools is not possible with any other techniques. It is possible with the technique of using powder metallurgy. The system having some disadvantages, we will study one by one. While powder metallurgy offers a unique way to create complex parts, it comes with some drawbacks also. It gives a unique property but is having some drawbacks. Size and shape limitations. The size and shape of PM parts are restricted by the pressing equipment. Large or very intricate designs are difficult to impossible to produce due to limitations in press capacity and powder flow. With the help of powder metallurgy components, size and shape limitation is there and complex parts cannot be manufactured because this in this process the compactness of the component takes place. So it depends on size and shape. So with the help of the dimensions, it is possible to give only that required shape and size. In large and shape and size is limitations for this process because of the powder flow, strength and density. It is a very important part as far as their mechanical engineering applications are concerned. PM parts are typically have some porosity, tiny holes from the powder compactness process. I already told that powder metallurgy components are manufactured with the help of compactness process. So during compactness process, there is some porosity is there, that is some tiny holes are there. This can make them to slightly weaker and less ductile, that is flexible compared to parts made from traditional metals like forging. So we will, because of that porosity or that teeny holes, we are getting weaker or less ductility of the parts compared to that forging operations. However, advancement in sintering technique are improved the density and strength of PM components. But the advancement is that after that compactness, we are heating that powder metallurgy component through some temperature and through the sintering technique there is some improvement in a density as well as in the strength of powder metallurgy components. Applications that powder metallurgy components having wide range of applications. It includes it find application in several fields such as automotive, that is automobile, defense sector, high temperature applications, aerospace applications, atomic energy, etc. We will study one by one applications. First is the automotive application. The powder metallurgy components manufacturing by combining and sintering, that is manufactured from powder of metal and metal or non-metal, can be used in automobile applications. It is used in defense applications and high temperature applications, because I already told that tungsten or other mixtures can be manufactured with the help of powder metallurgy, which with cast iron with a high temperature. It is used for aerospace application. It is again for that high temperature application, atomic energy application. There are some other applications are there. We will study that one by one. Powder metallurgy is a versatile process used across many industries due to its ability to create complex, high precision parts in a cost effective way. Here are some of the key applications. First, automotive industry, that is automobile industry. That powder metallurgy parts thrives in the automotive sector for mass production. Integrate components like that gears, bearing, engine components, that is wall sheet and gags, and structure parts, mirror mount, exhaust system elements, or can be manufactured by powder metallurgy technique. The main is by using that PM technique, gears and bearing as well as engine parts are manufactured with the help of this PM technique. The near seed shape capability of powder metallurgy minimizes material waste and machining, reducing cost. This technique is used because the components manufactured from powder metallurgy technology required no machining or minimum machining, so reducing cost, and there is no any material waste. Second application is the aerospace industry. PM is a crucial for aerospace application that demand precision and high performance. Components like turbine blades, landing gear parts, and rocket engine parts benefits from powder metallurgy's ability to create lightweight, high-strength components. The components produced from powder metallurgy having advantages, it having high strength and low weight. So it is used in the aerospace industry like to manufacture the components like turbine blades, again landing gear parts and rocket engine parts similar to that automotive industry. Powder metallurgy devices also find some applications in medical devices. PM is valuable in medical application due to its biocompatibility, material options, and ability to create intricate parts. That complex part can be manufactured with the help of PM technique, and these parts are biocompatible, that is useful for implant, human implant. So it is used in a bioparticle material. Artificial joints, dental implants, that dental implant, that is teeth, can be manufactured by PM technique, and other surgical instruments are some examples. That artificial joints, dental implants can be manufactured with the help of PM technique. Consumer goods, PM, that is powder metallurgy cost effectiveness and design flexibility make it suitable for various consumer goods. Application includes application parts like knobs, gears, tools, that is blade, and electronic components like heatsink, EMI, RFI shields. Other applications include that powder metallurgy find use in various other sectors like firearms, oil and gas, that is drill bits, and other even processing, food processing equipment. Its ability to produce parts with unique property like porosity filter or controlled magnetic property, that is electrical component, broadness and its application. I already told that it gives unique property, so it is used in various applications. Thank you.